Okay, I'd like to just again review the quartiles with you. Remember, quartiles divide your data into basically 4 pieces, okay? So that the median is actually the second quartile, okay? And the median basically has 50% of the values below it. Remember that your data has to be in order. Don't forget to order your data. Okay, that's something that's often forgotten. Okay, so here at Big Bank, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. So n is odd. So the median is going to be that center value right here. Okay, so we've found the median before. The median is the same as the second quartile. And so that median is going to be 7.2. Okay, the first quartile is found then by taking the values below the median right here and finding the median of these values. And so the first quartile, there's 5 values below here. The first quartile then is going to be 5.6. Okay, and then the third quartile is going to be the median of the values above the median. And so again, there's 5 values, and that middle value here is going to be the third quartile. So that's going to be equal to 8.5. So the third quartile has 75% of the values below it. I do want to make the comment that people calculate quartiles in many different ways. It does say that here. So they don't universally agree on the procedure, but essentially whatever procedure you use, it's going to get you approximately in the right place. So we're going to be using this method. Let's do the same thing for Best Bank, okay? We find the median by, the first quartile, which is the median, by just finding, in this case, that center value. The center value, since n is odd, you're going to notice that this is also 7.2, okay? In the same fashion, the lower quartile, or that first quartile, is the median, of the lower values here below the median. And so this is going to be the first quartile, and in a similar fashion, this will be the third quartile. So we have a 6.7 and a 7.7. So that's how you find the quartiles. The quartiles are part of the 5-number summary that we use to create a box plot. Okay, and so here we have some box plots. I don't know how this got erased, but this should have an A right here. I don't know how that happened. So we have 3 data sets, A, B, and C, 3 box plots. I do want to mention that there are different types of box plots. This is called a skeletal box plot, because we're not going to be doing hinges and all that sort of thing. This is just the very basics, and it uses this 5-number summary. Okay, what is the 5-number summary? Well, it's the lowest value or the minimum value. Okay, so I'll just call this min for minimum. Actually, let me write this over here. The minimum. The first quartile, which is Q1. The median, which is actually that second quartile. They're basically the same thing. The third quartile. And then the highest value in the data set, which is the max. Okay, and so you can use these to construct a box plot as you saw on the PowerPoint. And in a minute, we'll do some more examples, or in another video, actually, we'll do some more examples using box plots. But for now, I want to make sure that we can find all these values for these three data sets, okay? So let me write down A, B, and C, okay? So first thing we want to do is find the minimum value. And remember that this whisker goes down to the lowest value here. So hopefully you can see that for all three data sets, the minimum is 5. Okay? Okay? The box is constructed so that the left side of the box is the first quartile, and the right side of the box is the third quartile, and that line that you see right in the middle is the median, okay? So we're gonna start off with, for each data set, let's find the first quartile. So the first quartile is gonna be right at the edge of the box. So for these first two data sets, it's actually the same. We're gonna have a first quartile, as you can see there, of 10. Then on this third one, you can see that further over, the first quartile for the third data set, or for C, is going to be 20. Again, for A and B, the median, which is that line that goes through the box, the median is the same. And in both of these instances, it's equal to 15. Whereas in the third data set, in C, you can see that it goes right there through 30. Okay. Okay. Then the next thing they want is the third quartile, which is going to be the right-hand side of the box. And now they're all different. So we're going to kind of have to see here for A, it looks like that upper quartile, or the right-hand side of the box, the third quartile, is going to be 20. For the B data set, it's going to be 25. And for that last data set, it's going to be equal to 35. Okay? And then finally, the maximum value, it will be the end of the whiskers here. So in this case, the maximum value is the same for B and C, but not for A. For A, you can see it's equal to 25, but for these two data sets, for these B and C, these two data sets, the maximum value is 40. Okay? Now it says, describe the shape of the distribution of each data set. So let's go through the first one. So for the A data set, hopefully you can see here that the median's here right in the middle of the data set, and everything looks very, very symmetric around the median, okay? So in this set, the data set is going to be symmetric, okay? In B, what you'll notice there is that the data is not symmetric. In fact, we can see that in both B and C, the data is not symmetric, which means the data is skewed. But the question is in which direction? So let's look at the B data set first. What you're going to see is that, remember that this box contains 50% of the data. So 75% of the data is over here on the left, right here, right? And so we have most of the data on the left, and so there's very less data here on the right. And remember, we say that when it's not where most of the data is, but more about the tail, this is going to be then a distribution that is skewed right. In this case, you see, remember, this is 25% of the data falls below the first quartile. So 75% of the data is on this side and only 25% is on this side. So there's less data over here, making this a distribution that is skewed left. The next thing it asks here is which one of these data sets shows the smallest variability. Remember, variability is how spread out the values are. So you can see a couple things. You can see that this has the smallest, the least variability. Notice that this has not only a small box, meaning that the middle 50% of the data is not very spread out comparatively to the other two data sets, but the maximum and minimum value are closer together. So you can see that these are much more spread out. So the data set that has the lowest variability is going to be A.